All right, hello, Algebra 2. Today we have lesson 7.2, factor, solve, and graph. Cubic polynomials. So cubic polynomials means that they are, oh, this is a typo. This is supposed to be x cubed. I don't know what I was doing there. All right, so means that they are cubic, x to the third power. And so all the polynomials that we'll see today are cubics. And we're going to be connecting, factoring, solving, and graphing polynomials. You'll want to use your calculator to help today, but for the most part, you probably won't need it. Once you get the hang of it, it's really easy. And I think super fun, but that's just me. All right, so you have a worksheet today. So again, please upload that OAD. Upload it to Student View. And if you have problems with it, please see me in office hours so we can figure out how to make it work. Student View. All right. So you should see that in Student View ready to go for you. So factor and solve. We've actually done this before. When we are factoring, the first thing we want to do is ask ourselves, is there a greatest common factor? And so when I look at these two terms, I see that they have an x in common, but they also have a 3 that we can take out. So in this case, there's a 3x. So I'm going to take out a 3x. And when I take out that 3x, I want to ask myself, well, what's left behind? Well, we're technically dividing each term by 3x, because when we're factoring actually means dividing to find the factors, all right? Meaning what things multiply to give us the result. So one of the factors is 3x. So we're going to unmultiply that, which means divide. The 3's would cancel out, and x cubed divided by x would leave an x squared there. Here, 27 divided by 3 is 9, and the x's cancel out. From here, x squared minus 9, that is difference of squares. So then the second thing we want to do is factor or double bubble. And so this, x squared minus 9, we're going to double bubble even more. And we're going to bring that 3x along for the ride. And we ask ourselves, what times what is x squared? Well, x times x is x squared. And we want to know, hey, last times last has to be negative 9. What times what is negative 9? Well, positive 3 and negative 3. And then we do the zero product property, which means we're going to set each factor equal to 0. So here I'm going to say, hey, 3x is going to set equal to 0. X plus 3 is going to set equal to 0. And x minus 3 gets set equal to 0. And we can solve for x, which is really easy to do. And this is kind of a step you can skip. But we can go ahead and divide by 3. Well, 0 divided by any number is 0. So there's one answer. We're going to go ahead and subtract 3 here. So we get x equals negative 3. There's an easy answer. Could I have just gone there from here right to this? Absolutely. Here we would add 3 to both sides. So we get x equals positive 3. And again, if we were at x minus 3, could we jump right to x equals 3? Absolutely. But this is the math. This is why. So we have these lovely solutions for x. If you were to take these solutions and plug them into the original, they would equal 0. All 3 of them. You'll also notice that there are 3 solutions, and this is x cubed. Very important. All right, so we're going to do the same thing, but now we're just adding on one more step. So example 1 here is find the zeros by factoring, sketch the polynomial, label the intercepts, and then use the calculator to check. All right, so you'll notice we have y equals. That's y equals so that we can set it, put it into our calculators. If you don't have your calculator, you can use Desmos as well. So I'll write that down. Desmos.com is a great graphing calculator, and you can type this equation into your calculator, into Desmos.com, and it's going to give you a really good graph. So what does it mean? So what I want to do is actually to find the x-intercepts. So if I wanted to find x-intercepts, then I would need to plug in 0 for the y value. And so I'm going to do that. So to find the x-intercepts, I'm going to plug in a 0 for the y. And then that's going to allow me to solve for x. You'll notice there's only x's left. Well, let's start by factoring. First thing first is a GCF. So I notice that each term has an x that I can take out. So I'm going to undistribute an x. If I take an x out, what's left behind? Well, all these powers are going to decrease by 1. So x squared plus x, and then a minus 6. Then we want to go ahead and factor further by double bubbling. So we're going to double bubble this trinomial. And take that x along for the ride. Don't leave it off. Also, make sure you keep your equation. It's really good math. If there's an equal sign, it always needs to be there. So let's unmultiply here. What times what is x squared? Well, that's easy. X times x. Then last times last has to be negative 6. What times what is negative 6? We have quite a few choices. Negative 6 times positive 1. Negative 1 times positive 6. Negative 2 times positive 3. Negative 3 times positive 2. All of those are factors of negative 6. So which one do we want? We want this one. Why? Because that's how we get the positive 1 when we add them together. So negative 2 and positive 3. So we've done this before. This is all review. But hopefully it's a good review. And we will do this for another month here, actually longer. We won't stop factoring. So it's really important that you get it. Then what we're going to do is set each factor equal to 0. Each bubble gets set equal to 0. And when we do that, again, just like before, I'm just going to say x equals positive 2. And here, x equals negative 3. So these are all the x-intercepts. Well, that's kind of handy. We can then, x-intercepts, zeros. They said find the zeros by factoring. Zeros are the same as x-intercepts. It's just a fancy word. Why are they zeros? Well, they're zeros because the y has a value of 0. If we wanted to write them as ordered pairs, it would be 0 for x, 0 for y, 2 for x, 0 for y, negative 3 for x, 0 for y. And that's why they're called zeros. They're also x-intercepts. So we're going to graph them really easily. This is all you have to do. Here we have 0. I'm going to make a nice big dot on the x-axis at 0. Right here, I'm going to call that 2. Make a nice big dot on the x-axis. That's the x-intercept at 2. And then here at negative 3, I've got a nice big dot at negative 3. Now, this is a cubic polynomial, and it's positive, which means it's going to go start low and end high, sort of like a positively sloped line, okay? So it's going to start low and end up high. It's like increasing, going low to high, but we have to cross through each of these zeros. So we're going to start low and pass through each of these zeros in a nice smooth curve. And that's it, ladies and gentlemen. You just graphed your polynomial. You'll notice they didn't say anything about the y-axis because it doesn't matter. But let's go ahead and check. And I'll use the Casio on the next one. But we can go ahead and type in x caret 3 plus x squared minus 6x in your y equals menu. And then just do a zoom standard. Zoom 6 is a standard 10 by 10 window. And you can see that it looks almost exactly the same as what we graphed. And the y-axis, we're not going to care about. This is all we need to do. Label those x-intercepts. Normally we would say y-intercept as well, but this is also the y-intercept. It's an x-intercept and a y-intercept. 2 for 1. All right, let's look at this one. I'm going to highlight that this was a positive x cubed. That was the leading term, was a positive. So we're going uphill, positive direction. Okay, let's look at this one. Notice this is negative. What do you think it's going to look like? Well, if you said downhill, you're right. It should start up high and end down low. Really important that you see that. So we're going to pay close attention to that. The very first thing I'm going to look for is my GCF. And when I look at this GCF, if there's a negative, I want to take that out. So in this case, a negative 2x is going to come out of my function. To find the zeros, I set y to 0, and I'm going to take out the GCF of negative 2x. When I do that, I have x squared left behind. When I divide this by negative 2x, positive divided by negative is negative. 32 divided by 2 is 16, and the x's cancel. And then from here, I'm going to double bubble whatever's left over. Everything you have today is the same exact pattern. So just to get you used to doing this again, x times x is x squared. And then we want to ask ourselves, hey, what times what is negative 16? Positive 4 and negative 4. Was that the only choice? No, there were lots of others. We could have done negative 16 and 1, negative 1 and 16, negative 8 and positive 2, negative 2 and positive 8, but negative 4 and positive 4. If you had chosen one of these others, well, this would have given you a middle term of negative 6x, but that middle term is missing. Here, when you choose this one, it adds to be 0. It cancels out that middle term. Notice it's not a trinomial, it's just difference of squares here. All right. And again, we're going to set each factor equal to 0. So here, negative 2x gets set equal to 0. We would divide by negative 2, but it's just 0. X plus 4 gets set equal to 0, and we'd have to move the 4 over, so that's why it becomes negative. X minus 4 gets set equal to 0, and we'd have to move that 4 over, which is why it turns positive. So here are our x-intercepts. We're going to go ahead and plot them, and all you have to do is label it. You don't have to make a whole lot of tick marks. I just don't care. If you plot a point and label it 4, and you plot a point and label it negative 4, it is. That's it. It is labeled. That's what it is, without a doubt. Now, because this has a negative in front, just like a negatively sloped line, it's going to go downhill from left to right because it's negative. So we're going to start up high, and we're going to pass through each of these zeros one time. And we'll talk more about that because that's not the only thing they can do, but that's what these do. And again, you can use your calculator to double check to make sure you did it right. But hopefully this is, you're kind of like, wow, this is kind of cool. So negative 2x to the third power plus 32x. My window is a little bit messed up. I'm going to go to my viewing window here, I think, and do shift viewing window and the STD. Bad name. There we go. Resets the window. Now you look at this, but you saw how it drew. And this is what it looks like, but you'll see how it's missing the sort of the top and bottom of the curves. And that's because we're stopping at a negative 10 and positive 10 window. If we want to, we can make that y-axis a little bit taller by changing the viewing window. And it's the same on the TI. You press window. So we're going to go to window. And I want my y minimum, let's try negative 20, and my y maximum to be positive 20. And so you can change your y min and your y max to make it taller. And then we're going to exit and graph. And we're almost there. So maybe we'd want to do it some more. I'm going to go ahead and do that just so you can see. Let's try negative 30 and positive 30 for the y min and y max. And, oh, not quite there yet. Do it one more time. Let's go. I'm just going to say negative 50 and positive 50 just so we get it done. There we go. So you can see how it started here up high on the left, and it passes through negative 4, 0, and positive 4. Now, when you're doing your homework, could you just simply graph this and draw the graph using your calculator? Sure, absolutely. But you will get no credit unless you have these wonderful steps worked out. All right, it should be perfectly logical to me what you are doing, without a doubt. No work, no credit, ladies and gentlemen. No work, no credit. All right, here we have some more. We're going to start by finding the zeros here, the x-intercepts. I'm going to look for the GCF here. I notice that everything has an x and a 2, and there's a negative in front. So I'm going to take out a negative 2x. When I take out that negative 2x, I'm left with x squared, negative, I've got to divide those, that's going to turn positive 5x. And then here, this is going to change to a positive 4. How do you know if you did that right? Really important. Well, we just unmultiplied. So if you were questioning yourself, you could always just distribute it back and make sure you get back to where you started. So negative 2x times x squared, well, that gives me negative 2x cubed. Negative 2x times 5x gives me negative 10x squared. Negative 2x times 4 is negative 8x. So you can always redistribute. Then I'm going to go ahead and double bubble here. X times x is x squared. What times what is positive 4? Positive 4. So you could have 4 times 1 or negative 4 times negative 1. You could have 2 times 2 or negative 2 times negative 2. Here, the signs have to match, so we get a positive result. And which one's going to give us a positive 5? Right here. Positive 4 and positive 1. And again, if you wanted to distribute this together and combine like terms, multiply it out and you'll get back to what we started. We're just doing it in reverse. Now we can set each bubble equal to 0. So this is going to give us x equals 0, x equals negative 4, and x equals negative 1. So I'm going to plot those x-intercepts, those zeros. Here we have a negative 4. Oh, and here we have a negative 1. Really simple graph. It does not take any time. Don't obsess over it. Let's see, which direction does this cubic go? It's got a negative in front, which means it's like a negative sloped line going downhill from left to right overall. And so we're going to start high on the left, and we're going to cross smoothly through each of these zeros. And there you have it. It's a fantastic graph, and it should be similar to what you'd see on your calculator. Now, here we have a function that is out of order. So I'm going to rewrite this in standard form because it's so much easier when it's in standard form. So I'm going to rewrite this. I'm going to put my leading term in front. So we have negative 2x squared plus 50. And now I'm going to go about the process. So if you see something that's out of order, go ahead and just rearrange it. It's so much easier. So what's our GCF here? It's got a negative, so definitely take that out. It's got a 2, but that's it. So, well, that's interesting, isn't it? I wonder, let's go ahead and graph it. This is interesting. It's not a cubic, is it? This is review. Negative 2. So if I take out that negative 2, that's going to leave me with x squared and then minus 25. And how do I know I did it right? I just redistribute, make sure I got everything. So negative 2 times negative 25 gives me that positive 50. And then from here, I can double bubble. So we have x times x is x squared. What times what gives me negative 25? Well, negative 25 and positive 1, or negative 1 and positive 25, negative 5 and positive 5. And that's the only one that's going to cancel out the middle term. So negative 5 and positive 5. Difference of squares. Now, when we go to set these equal, does negative 2 equal 0? What's the difference here? This one worked. Negative 2x equals 0. You can solve for x there. Here, there's no x here. You can't, negative 2 does not equal 0. Negative 2 times something could equal 0, but there's a big difference, so be careful. This does not have an x. I can't set negative 2 equal to 0. Here, x minus 5 equals 0. When we move the 5, it becomes positive. And here, x plus 5 equals 0. When we move the 5 over, it becomes negative. So what is this then? This is not a cubic. This is not a little stretchy S sort of shape. This is x squared. This is a parabola shape. And this is review. So we're going to graph this. We have -5 and +5. So the question is this an up parabola or a down parabola? Of course, if you weren't sure, when in doubt, graph it out. But it does have a negative in front. Normally, x squareds go up. But here, because of the negative, it's a downward parabola. Okay, and again, when in doubt, graph it out. You can absolutely plug this in to your calculator and see what it looks like if you weren't sure. But hopefully you won't have any trouble with this. That's it, ladies and gentlemen. This is a great worksheet. Please get it done and upload it to Student View. And again, make sure that you're showing these steps. All right, if you don't have this work, you don't get credit at all. You do need the graphs as well, but they're so simple. So it just takes a second. Folks, have a fantastic day.